Now, the next part of lesson 1.3 goes over a couple of unique instances which can happen when you solve linear equations. So we're going to look specifically at problems 4 and 5 of the instructor-led problems, as you see them on the screen there. And we're going to go through solving them and see what happens. This is a good exercise to see what types of solutions we're going to be looking for in this case. So normally, like we saw in our last few problems, when we solve a linear equation, we come out with being able to get our variable equal to a number. Most of the time, you can do that. Whether, like in the last problem we just did, we came with a variable equal to 4/3, or the problem before it, we saw that we came out with a variable equal to 4. So we're going to do the same steps that we did on those previous problems to these two problems here. So step 1, always, is to simplify the left-hand side and then simplify the right-hand side as much as I can. And essentially that means distribute to get rid of parentheses and combine like terms. So if we did that over here, the first thing I'd do on the left-hand side is distribute this 7. So we'd end up with 7x plus 35. And that 7 would distribute inside the parentheses, but it would not be applied to the minus 10 out here because the minus 10 is outside the parentheses. So we get 7x plus 35 minus 10 on the left-hand side. There's really no parentheses to distribute on the right-hand side, so I'm going to leave, and I'm just going to write 7x plus 20 minus 5 in that step. All right, so no parentheses to distribute. However, on both the left and the right-hand side, there are like terms. So we have 7x plus 35 minus 10. 35 minus 10 will combine to give you 25. On the right-hand side, we end up with 7x plus 20 minus 5. So 7x plus 15 on the right-hand side. Now, in all the previous problems, what I did in the next step is I got all of the variable terms on one side. And the way to do that is to look at the variable terms, for instance, on the right-hand side and say, well, the variable term here is 7x. So let's get rid of that. Now, if we were to get rid of this 7x, we'd have to subtract 7x from the right-hand side. In order to maintain balance, we would have also had to subtract 7x from the left-hand side. I'm going to do this. Oops. I kind of screwed that up. All right, there we go. So subtract 7x from the left-hand side, subtract 7x from the right-hand side. And here's where the weird thing happens. Yes, on the right-hand side, 7x minus 7x gives me 0x, or just 0. So on the right-hand side, I get just this 15, which is what I wanted. Remember, I wanted to get rid of the terms with the variables. However, by doing so, that also gets rid of the 7x on the left-hand side. 7x minus 7x becomes 0. And I end up with just 25. Now, 25 equals 15. That's actually a false statement. I hope we're all smart enough to know that. 25 and 15 on the using the real number system, that always has to be a false statement. All right, so let me write just that behind this. So that is false. So what does that mean? When my x's drop out and I end up with a false statement. Well, what that means is no matter what I would have plugged in for this variable x here, I would have always came down and got a false statement. So if you plugged in the number 2 into both x's here and then simplified, you would have gotten a false statement. If you'd plugged in 3 and simplified, you would have gotten a false statement. If you would have plugged in 4/3 and simplified, you would have gotten a false statement. In other words, no matter what number you plug in, you end up with a false statement, which means that there is no number that you could plug in which makes this equal. So think about that. I'm going to write that down. No number will make this equal. In other words, no number that you can plug in for x. Okay? And so when we get a situation where that happens, where no matter what number I plug in, I can't get it to work, that means that there is no solution. So that's what we write as far as the official no solution. And again, a lot of times when you see a no solution, you'll just highlight that, circle it, put a box around it, something like that. So no number, there's no number you can plug in to this original equation in for x and make a true statement. So no solution there. By the way, you'll see a lot of times there's a fancy symbol for no solution as sort of a shorthand. Okay, it looks like a 0 with a slash through it. When you do it on your on this system, it looks like this. So it looks like a 0 slash through it. That's the shorthand symbol for no solution. A lot of times in mathematics, we create these shorthand symbols for something that stand for other things, just so we don't have to write out the words no solution every time. So if you get to a situation like this, you can either write out the word no solution, or you can just write a 0 with a number, a slash through it. That means there's no number that will work. Okay. Now let's take a look at the other problem. The other problem that I said we're going to go over in this video is this one, 3x minus 2 times 5 minus x equals 5 times x minus 2. Okay, you can see the parentheses there. So the first step is to get rid of the parentheses by distributing. So we have 3x minus 2 times, in parentheses, quantity x minus 5 in the parentheses. So the minus 2 is going to distribute. It's going to multiply by 5. That'll give me a minus 10. When the minus 2 distributes and multiplies by the minus x, that gives me a plus 2x. Be careful there. Negative 2 times negative x is a positive 2x. On the right-hand side, I have parentheses 5 times x and then 5 times negative 2. 5 times x is just 5x. 5 times negative 2 is negative 10. So let's combine like terms. On the left-hand side, 3x plus 2x on the left-hand side combines to give me 5x. The minus 10 is a constant that doesn't do anything as of yet. In other words, I can't combine it with anything else. 5x minus 10 on the left-hand side, that's as simplified as it gets. And the 5x minus 10 on the right-hand side is also as simplified as it gets. So there you go. We got 5x minus 10 equals 5x minus 10. Now, if we're going to get rid of the 5x here on the right-hand side, then we'd have to get rid of a 5x on the left-hand side. If we had to get rid of a 5x on the left-hand side, we'd have to get rid of the 5x on the right-hand side. In other words, for subtracting 5x from both sides, you end up with a statement that says negative 10 is equal to negative 10, which is obviously a true statement. Let me tab that over, which is obviously a true statement. So what that means is no matter what number you plug in for x into your original equation, it is always going to come down to giving you a true statement. Now, it might not always be negative 10 equals negative 10. It might be 30 equals 30. It might be 2.5 equals 2.5. But it's always going to be true. All right, no matter what number you plug in for x, here, 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 and here, you're going to end up with a true statement. And so that means that any number I can plug in for x will be a solution to this problem. Any number will be a solution. All right. And so what we officially say is that the solution is all real numbers. Okay. We talked about real numbers briefly in section 1.1. That's all the numbers on the number line. So we would just highlight all real numbers. Okay. Either circle it, box it, whatever we do. Okay. All real numbers work as a solution. Now, one little other thing that you'll see is that there's also a shorthand symbol for all real numbers. Okay, all real numbers as a shorthand symbol. Let me see if I can get it here. Microsoft does it this way, where it has double lines. It's basically a capital R with double lines. Now, Microsoft does the double lines on both the upper line and then the arch around. Some people will write all real numbers. Let me try it this way. Let me try to freehand it. So they'll write all real numbers like this. They'll write two lines on the left and then just a single line on the arch and then the kick out there. All right. So some people will write this way, that as the symbol for all real numbers too. Okay, so some people do double everything's, other people just do double left-hand side and then single arch. Either way you do it, all real numbers is the solution. And again, you can shorthand that by that symbol. All right, so this is what happens in terms of these two unique situations. Now, these are unique situations. They don't happen often, but they are something that you'll have to come across in terms of the test, in terms of the homework, that sort of thing. Okay. And by the way, that's what the book is trying to explain here. They call this true equation, the identity equation. They call this just false equation, the contradiction equation. You can see that they have the symbol for no solution there as well. Again, 0 with a slash through it. Okay. In mathematics, that 0 with the slash through it is technically called the empty set. But there you go. All right, so as you're solving, if you come out with a true equation, you end up with an all real numbers solution. And I say true, meaning it's always true. If you come out with an always false situation, then it's a no solution situation. So there you go. Now in the next part, we'll talk about other things that could happen, specifically how to deal with decimals and fractions.